This video is designed to give you more practice and some reminders for linear programming. So I'll let you read this. I'm not going to go crazy and read the whole thing for you, but a couple reminders in terms of what we want to do here. The first thing we want to do is define our variables. Fortunately, this problem defines them for us. So N is the number of notebooks, and F is the number of folders. So what we're going to do is I'm also going to label my axes so that I know that N and F are for notebooks and folders. Now, if I'm graphing them on a calculator, N would be X and F would be Y because that's kind of how we want to look at it. The next thing we want to do is write our objective function. So we always want to write our objective function. Our objective function in this case is it appears that we are trying to maximize profit, correct? So since we're trying to maximize the profit, what we can do is we can look at profit equation or try to figure out things in here that are talking about profit. So notebooks give 50-cent profit per unit and folders give 30-cent profit per unit. So because that's true, our objective function is going to be 0.5 or 0.50 n plus 0.3 F. So 50 cents for every notebook, 30 cents for every folder, and we are trying to maximize that. The next thing we want to do is write our constraints. So let's see what kind of constraints we have here. It appears that we have a constraint where the notebooks, I should probably use a different color. So the notebooks cost 30 cents per unit and the folders cost 15 cents per unit. So those costs actually matter because Mr. Mead only budgets $120,000 weekly. So because that's the case, we are going to have to write a constraint for that. So 30 cents for every notebook plus 15 cents for every folder, and that must be less than or equal to 120,000 for the week. Um, so 0.3n plus 0.15f is less than or equal to 120,000. We also must produce at least 100,000 notebooks and at least 150,000 folders per week. So we have a couple more that we have. The notebooks must be greater than or equal to 100,000. And the folders must be greater than or equal to 150,000. And then finally, we also have a maximum of 500,000 products that can be made in a week. So that results in another constraint. That means the total number of notebooks and folders must be less than or equal to 500,000. Now, after we graph all of this, we're going to want to graph things. So I'm not going to spend the time scaling and everything else. That's something that you can do. But notice that this will be a vertical line somewhere. This will be a horizontal line somewhere. And then we will have two other lines that have negative slope that are going on the graph. So both of these lines will have a negative slope. What ends up happening after you graph all of this, and I did this on Desmos in order to save some time, this is the kind of graph you get. Now, one thing I want you to notice that I did in this particular situation is instead of having all of the products have 120,000, 100,000, 150,000, 500,000. I just ignored all of those thousands, and then I know that that's going to be part of my answer later on, but I'm just basically multiplying everything by 1,000 when I get done. So that's going to save me a lot of time. What I end up finding when I find all these intersection points is that I end up with three intersection points that I really have to check. So 100 comma 400, 300 comma 200, and 325 comma 150. And then this one will definitely not maximize my profit. It is an intersection point, but it will not maximize my profit. So I have to take a look at our objective function, which is 0.5n plus 0.3f, and I have to see which one of these maximizes it. We'll take a look at all three of these points that might possibly maximize it. 100, 400 probably won't, but it's above 100, 150 on the line, so we should probably check it anyway. So 0.5 times 100,000 notebooks plus 0.3 times 400,000 notebooks gives us 170, which represents a profit of $170,000 in a week. Let's try the other 2 points. So 300, 200 gives Mr. Mead a profit of $210,000 in a week, and 0.5 times 325 plus 0.3 times 150 gives him a profit of 207.5, which when we multiply by 1,000 is $207,500. The winner is this case, not by much, but it is a winner. So the winning case is a $210,000 profit, which occurs at 300,000 notebooks and 200,000 folders. Remember to multiply by 1,000 at the end if you took the thousands out like I did when you graph the problem.